Now irreversible. Sea level rise. Melting Arctic ice. Ocean warming. Ocean acidification. Irreversible, set in stone.
Facebook. Feedbacks and interaction between feedbacks. There are numerous self-amplifying feedbacks that accelerate the temperature rise. One of them is the water vapor feedback. Just the temperature rise itself will cause more water vapor to be in the atmosphere. The image illustrates the mechanism of how multiple feedbacks accelerate the heating up of the atmosphere. Feedback number 1. Albedo loss as sea ice melts due to rising temperatures and due to the ice getting covered by soot, dust, algae, melt pools, and rainwater pools. Feedback number 14. Loss of the latent heat buffer. As sea ice disappears, heat can no longer be consumed by the process of melting, and the heat will instead go into increasing the temperature. Feedback number 16. Eruptions of seafloor methane. As more heat reaches the seafloor of the Arctic Ocean, sediments and hydrates contained in them destabilize, resulting in methane releases. Feedback number 25. Extra water vapor feedback. Rising temperatures will result in more water vapor in the atmosphere. 7% more water vapor for every 1 degree Celsius warming, further amplifying the temperature rise, since water vapor is a potent greenhouse gas. Feedback number 19. Distortion of the jet stream as the temperature difference narrows between the Arctic and the tropics, in turn causing further feedbacks to kick in stronger, such as hot air moving into the Arctic and cold air moving out, and more extreme weather events bringing heavier rain and more intense heat waves, droughts and forest fires that cause black carbon to settle on the sea ice. Feedback number 28. Freshwater lid on the North Atlantic. Melting of sea ice and glaciers and thawing of the permafrost results in meltwater accumulating in the North Atlantic, where it forms a cold freshwater lid on top of the water. This lid grows further due to more rain falling on top of this lid. This results in less evaporation and transfer of heat from the North Atlantic to the atmosphere and more ocean heat getting carried by the Gulf Stream underneath the sea surface into the Arctic Ocean. There is interaction between feedbacks. The image's focus is on illustrating the mechanism rather than the proportional contribution or the order of feedbacks over time. Sea ice decline comes with both loss of albedo and loss of the latent heat buffer, each of which will accelerate the temperature rise of the water of the Arctic Ocean, thus contributing to the threat that hydrates contained in sediments at the seafloor of the Arctic Ocean will be destabilized, which in turn threatens to cause eruption of huge amounts methane. A further danger lies in changes occurring to wind and ocean current patterns. The temperature rise will cause stronger wind, waves, and storms, as well as deformation of the jet stream. In addition, the temperature rise causes loss of reflectivity of clouds and more ocean stratification, exacerbated by more freshwater accumulating at the surface of oceans, due to stronger ice melting, due to heavier runoff from land and rivers, and due to changes in wind patterns and ocean currents and circulation. In the North Atlantic, there is the additional danger that formation of a freshwater lid will cause huge amounts of ocean heat to be pushed into the Arctic Ocean and enter the atmosphere as sea ice disappears. Furthermore, developments such as rising emissions from industry, transport, land use, forest fires and waste fires, ocean acidification, and reductions in sulfur emissions can all contribute to further acceleration of the temperature rise.
Now irreversible. Sea level rise. Melting Arctic ice. Ocean warming. Ocean acidification. Irreversible, set in stone.